So any other questions till now? Am I going too slow, too fast? Yeah, I'll just quickly take you through the next slides. Okay. These are our complete range of controls available with us. So we have all the products from expansion valve to filter dryer to ball valves and electronic expansion valves, suction accumulators, oil separators, suction filters, liquid line filter with a normal filter dryer as well as like with a shell and all that. And we have HPLC cutouts. The complete product range is available. When it comes to controllers, we also have a digital controllers and all that is available. Yeah. So this is like highlighting the oil separator here. You know, like it is to take care of oil return. So generally it is not used in AC application, mostly used in refrigeration application. Even in AC application where there is longer length of pipe, people want to ensure that back to the compressor they try to use the oil separator. But rarely used in AC application, but largely used in refrigeration application. Then you have check valves as well. Some of the application needed check valves when it comes to multiple compressors like compressor racks. When you have a compressor rack with 5 racks in one this thing, 5 compressors in one rack. So where actually check valve is needed. So that is also available with us. Then we have filter dryers available to remove impurities as well as the moisture from the system. Then we have solenoid valves available. Then we have expansion valves, side glasses, moisture indicators are available. So moisture indicator is for both. So to ensure that you have sufficient refrigerant inside. The second one is to ensure that there is no moisture inside. Yeah. If you have a moisture, the color changes. You can identify that. Yeah. That is also available. So this color coding is based on the manufacturer. The color coding changes, but it is shown that on the top there is a sticker which will show like what is the color code for this. Then we have expansion valve. We have a normal expansion valve, thermostatic expansion valve, as well as we have electronic expansion valve being used for variable speed application nowadays. Yeah. Then we have ball valves. Ball valves are available in different sizes. We have accumulators. We also have accumulators for some certain refrigeration applications, and also accumulator used for fresh air AHU applications. So when it comes to fresh air AHU, the load keep on changing based on your ambient. So at low ambient condition, there is a possibility of liquid coming back to the compressor. To arrest that, a lot of manufacturers use accumulator in the suction when it comes to fresh air application. That's it on the product wise. If you have any questions on the product, actually you can take it. Otherwise, I can just take it through the next slide. Any questions?
Yeah, there is one question related to the hertz that you said this is a compressor will come 60 hertz to change to 50 hertz have to multiply
5 by 6
again
into 5 divided by 6 multiplied by 5.
5
Yeah, into 5 divided by 6. Yeah, divide by 6.
divide by 6. Huh?
Yeah, it is only 50 hertz. 50 and 60, no? Same thing.
Yeah.
So it's only RPM changes. So approximate capacity will be like you multiply by 5 by 6 means you are reducing the capacity because it is 50 hertz operation. So 50 hertz to 60 hertz you multiply by 6 by 5. So generally the capacities are given in 60. So that's why when you want to convert to 50, you just multiply.
Yeah, for example, if we have capacity 6,000, okay, that you have to multiply 5 divide 6.
5 by 6. That will give for 50 hertz.
50 hertz.
Yeah.
Okay, thank you.
Yeah. So the stall design is made based on the involvement of a circle. So you have a pipe where the thread is wound. You have a pipe and with the thread wound. So you are removing the thread from the pipe. When you remove the thread from the pipe, you draw a shape, right? You form a spiral. So what we do is you remove the thread from one point here. Yeah. So we have one more thread. So you remove it from the other point. So these two, like just opposite. You are removing from here and you remove this thread. Whatever you remove, form like this. For the other scroll, you remove it from here. It will be forming one more spiral, right? One more spiral. So these two things will be meeting at particular points. You can see these two threads will be meeting at this specific point, this point, this point. So that's how the scroll compressor design is formed. Yeah, you take it from different location, the thread, then this forms this particular design. So we have two scroll flanks in it. This we already seen like patented and all that. So we have two scroll flanks types. One actually we call it as a fixed. The other one is orbiting spool, rotating spool or orbiting spool or moving spool, whatever we can call it. Yeah. So this is the fixed scroll and this is the orbiting scroll. This will be get inserted inside the fixed scroll. Yeah, both are get coupled together to form different pockets inside. We'll just quickly look at the thing. These are two identical concentric scrolls, one inserted with other. This will be just inserted inside. Yeah. So one is stationary, this one is stationary, the other one is orbit around, that is rotation scroll or orbiting. Movement draws gas into the compression chamber. When it is moving, it will be drawing the gas to the compression chamber. The pockets, whatever it formed, there will be a crescent shaped pocket inside. I'm going to show you in the next slide. The crescent shaped pockets, the pocket's volume keep on reducing towards the center. Initially it will be bigger. When it goes towards the center, it keep on reducing. When you are reducing the volume, you are increasing the pressure. So that's what we are doing it here. Yeah, we keep on reducing the pocket volume. So maximum pressure will be reached at the chamber at the center, and it will get discharged. Release to the discharge port. Continuous operation due to simultaneous compressed pockets. So unlike a resin compressor has a suction stroke and the discharge stroke, right? Yes. But here, separate suction and discharge stroke. When it's taking place, suction also taking place. So that's why the noise level will be much lower, the vibration will be much lower. Because the refrigerant is at different pockets at different pressure at all the times. Yeah, I'll just quickly show that how it works. So this is this we call the Oldham coupling. This is to hold the orbiting scroll in place. Yeah, the orbiting scroll is connected to the crankshaft, to the rotor. So when it is running at 2900 RPM, so there is a centrifugal force formed in that. That centrifugal force only makes sure that both the scrolls are touching each other and contacting enough to not bypass the gas from one pocket to another pocket. Yeah. So this Oldham coupling holds this scroll in place, the bottom scroll in place. Look at the design here. The gas comes here. It will be entering both the sides. It will be entering here, the suction gas, it will be entering from here. So this gas goes towards the center. It will keep moving. The pressure keep increasing. This blue is a low pressure, then the medium pressure, then it gets into the high pressure, and from center it gets discharged. Okay, so it is a continuous movement. When discharge is happening, the suction is happening here. So that's why we say there is no suction and discharge stroke. It is a simultaneous compression process, simultaneous action and discharge. Yeah. We'll look at a small video on this. This is how it does. So you can consider the red one as a fixed scroll and the black one as an orbiting scroll. So this will be making the pockets here when it is moving. Okay, this is always in contact and force the refrigerant gas to go towards the center. Right? The pocket volumes are keep on reducing towards the center, so compression takes place. Pressure increases, it gets discharged from here. I'll just quickly run a small video as well.